Hey guys, it's Greg. I'm back with another course review, and today we're going to be looking at the Data Structures and Algorithms Specialization by the University of California, San Diego on Coursera. Man, that was a mouthful. So essentially, this is a set of courses that is going to really teach you data structures and algorithms. Other words that you might have heard around this are like leet code style questions or hacker rank, or maybe algo expert if you've heard of that paid program by Clement. Competitive programming. There's many different terms for this. It all means data structures, which is like, data, how do we store data, and algorithms, a set of rules which we perform on that data. Some data structures you may have heard of are, say, hash maps and dictionaries, lists, arrays. There's so many different types of them. You're going to learn about all of those. And the algorithms like, divide and conquer, greedy algorithms. There's so many different algorithms as well. And they're going to teach you about all of this stuff to the level that you need to know. And I don't think past it. And regarding programming languages for this specialization, they're going to teach it generally and then allow you to do the algorithmic assignments in whatever programming language you want. Python, C++, and Java, I think, are the three that they have. And those are, that should be easily enough. I bet most of you are probably going to do it in Python. And then the other ones, of course, if that's your tool as well, then go for it. So you may or may not have heard of these terms: runtime complexity, space complexity, or big O notation. This is essentially a set of ideas and mathematical tools that is used to analyze, how long an algorithm is going to take, or maybe how much memory it's going to consume. They're very important ideas, which is used throughout all of like leet code problems, hacker rank, needed by the FANG level companies in those interviews to solve those problems, and just to be a better programmer, because you will need to write optimized code. And without knowing what it really means to write optimized code and the data structures that are being used to do that, well, this specialization is going to really help you learn all of that. And let's take a look at it in depth now. So over here, they have Master Algorithmic Programming Techniques, advance your software engineering or data science career by learning algorithms through programming and puzzle solving. Ace coding interviews by implementing each algorithmic challenge in the specialization. Apply the newly learned algorithmic techniques to real-life problems such as analyzing a huge social network or sequencing a genome of a deadly pathogen. So that sounds pretty cool. They give you a sneak peek into some of the projects that you'll be doing, and let's get into it. So essentially, straight to the courses. So course 1, the Algorithmic Toolbox, very good ratings. This online course covers basic algorithmic techniques and ideas for computational problems arising frequently in practical applications: sorting and searching, divide and conquer, greedy algorithms, and dynamic programming. We learn a lot of theory. This is a theoretical course, okay? Keep this in mind. This stuff is a lot of theory, but it's really important theory and doesn't go into the useless stuff. So we will learn a lot of theory: how to sort data and how it helps for searching, how to break a large problem into pieces and solve them recursively when it makes sense to proceed greedily, how dynamic programming is used in genomic studies. You will practice solving computational problems, design new algorithms, and implement solutions efficiently so that they run in less than a second. Okay, that is hands down the best description I've ever seen for a Coursera course. They very clearly tell you, yeah, you're going to be learning about these various algorithms and the algorithms that you'll be looking at. It's not too much into the graph stuff. You didn't see the word graph here, and that's because graph algorithms will come later. But this is a very, very awesome way to start it out. People loved it, very high ratings. If you cannot get through the entire set of courses, I would at least recommend doing this course. It's going to really, really help no matter what kind of programmer you want to be. Next up in course 2, we have data structures. Now just to look at the ratings for a second, you can see they both have an average of 4.6 stars, which is probably the average on Coursera in general. It means it's very good. And don't be worried about the number of ratings drop off, like we have 7,000 or so less ratings here. But that just means that many people did not get through this course because they gave up too early and never saw this course. So people love this as well. A great course. A good algorithm usually comes together with a good set of data structures that allow the algorithm to manipulate the data efficiently. In this online course, we consider the common data structures that are used in various computational problems. You will learn how these data structures are implemented in different programming languages and will practice implementing them in our programming assignments. This will help you to understand what is going on inside a particular built-in implementation of a data structure and what to expect from it. You will also learn typical use cases for these data structures. Sorry for the jump, that description was not very helpful, so I had to jump into the course here and show you we talk about all of the common data structures. So it starts with arrays and linked lists, then stacks into queues, and then trees, and then you can implement those in your favorite programming language for their assignments. That is all in just week 1. Week 2 goes a little more complicated. Dynamic arrays and amortized analysis. Very important stuff, and we do an assignment there. So week 3, priority queues and introduction. Heaps, of course, which is pretty much priority queue. We have heap sort for priority queue. And, I'm not going to go into the rest here. So sorry for the jump again. Essentially, you're going to look at all of the common data structures and algorithms in course 1 and course 2. So what could be left? Well, actually a lot still. They didn't really include the idea of graphs before. So I don't want to get too into this, but basically what a graph is, well, if you take the word Facebook here, or also network, basically a graph is a good way to generalize the idea of a network. And so a social network, like say a person, they have friends with all of these people. And each of those people, well, they have friends with all of these people, forming what we call in math or computer science a graph. Now that might be confusing, especially if you've taken some of the analytics courses. You would know that a graph, generally a 2-dimensional graph, has an x-axis and a y-axis. That is not what we're referring to. A completely different idea. A graph is essentially a network or like a social network. We have nodes, which are like say a person, and they have edges, which is say their relationship to their friends. That is a graph, and that is what they're referring to here. Also, graphs you really do see all over the place when you're coding anything. You will find much of the time, hey, this is actually a graph. And you wouldn't really know that, and you wouldn't know the tools to perform with that unless you were to take a course like this. So I definitely recommend getting this far to course 3. It is really, really useful. Moving on to course 4. Algorithms on strings. Now, it's kind of a weird one because a string, what actually is that? Well, generally, a string is just an ordered sequence of stuff. And you might be surprised at the very vast and extremely difficult at times algorithms that you would need to perform on strings to get the most optimized or fastest answer. And so they're going to talk a lot about that. These are also one of the most common things to ask for any level of company, actually, especially lower level companies, kind of easier, like medium level jobs. They are going to really commonly ask algorithm type questions on strings. So definitely try to get this done as well. Okay, course 5, advanced algorithms and complexity. This is where I start to see a little bit of a drop off, in my opinion, as courses 1 to 4, I'd pretty much consider essential. And from there, you can probably go to LeetCode or HackerRank or whatever kind of platform you want to use to practice a lot and get pretty good at this stuff. Course 5 here, I would say that if you're doing this whole specialization, that you might as well go through it. Of course, there's some material in here that is interesting, and you will learn and get a better programmer out of this. But I think there's a little bit of a drop off. And so if you aren't planning on doing the certificate, getting the whole specialization here, then course 5 may be a bit of a drop off for you. And I would mostly just practice after course 4. But with that being said, this some of this more advanced stuff is what can really take, that extra step to get some of these jobs. So just letting you know, that's my opinion. And course 6, to finish it off, not going to go into the details. You do a cool genome assembly programming challenge. I'm not really going to worry about that. It's cool stuff. So what do I think about this? Really good. Courses 1 to 4, I think are just phenomenal. Getting a great introduction to the algorithmic toolbox and all of the common algorithms. And then data structures, all the common data structures. After that, they give you a dedicated course on graphs and a dedicated course on strings as well. This is going to really, really help you on your pathway to getting a software engineering based role, and I think it's a great set of courses. And in terms of the certificate, it holds a lot of value to get a data structures and algorithm specialization that actually has this much there, because most of these sort of data structures and algorithms courses don't go that much in depth. But this one goes pretty in depth. You're going to know this stuff really well at the end of it, and you're able to take that, go off to LeetCode and HackerRank and whatever. So again, in terms of software engineering jobs, pretty much all of them are going to greatly benefit from your skill set here. Many of them are going to ask sort of LeetCode or HackerRank style coding challenges in which you can take the skills that you've learned here, go off to LeetCode and HackerRank and really practice this stuff so that you can nail that portion of the interview process. Of course, the link to this is in the description below if you're interested in it. Otherwise, have a great day. I really hope that you have a good week or weekend or whatever it is, and see you later, guys.